All right, guys, time to get started. So what we're doing right now is we are going to be talking about scientific experiments today and what makes a scientific experiment and how they're different from your average lab activities. So what I asked you was, what are the key components of a scientific experiment? All right, and I get a lot of good answers. So for nearpod, something I can do is pretty easily is I can share answers. So if you shared something good, the key components of scientific experiment: control independent and dependent variables. That's excellent. So that's something good. Somebody posted something that they learned last week, which I appreciate. Put on your lab coat, safety goggles, gloves. Don't mix chemicals together. Good. So this is stuff that I'm looking for as far as answers. So something that sticks out to me, though, when you guys submit answers is stuff like this. All right? Validity. Now, I'm not saying you guys don't know what this means, but through my experience in teaching and interacting with students here at Withrow, I don't think I've heard any student use the word validity in a sentence. And it's not that, again, it's just not common words that you use in a classroom normally. So it's not that you don't know, it's just this might be Googled to me. So make sure you use common language or stuff that you would actually say, all right? Because like I said, there's no wrong answers. I just want to make sure that you guys understand the questions and you are comprehending what I'm putting down. All right, so Googled answers are of no use to me. All right, so as we go through today's Nearpod, I want you guys to be aware of how I'm going to grade it. So for the Nearpod grade, we're going to be basing this off participation. All right, participate in everything and you won't have anything to worry about. So during each activity, there's a participation percentage up in the corner on my screen that tells me how many people have participated in that slide. So the last one was 80%. That means 80% of the people turned in something. That's good. Since everything is virtual, this is how I can double check my attendance. So I take attendance and I go through, and then, for example, if say I marked you absent on accident, I can go back through the Nearpod and be like, oh yeah, duh, there they are. They were here in class today. Or if any teachers are asking me, hey, was so-and-so in class today? I'm like, yeah, look, and they participated. So it covers you too by participating. When I'm done, I'll see, I know this might be a little bit hard to see on the screen right now, but I will see a picture that looks like the one in the slide. And there's everyone's name, and then there's how they did on each part. So the polls, open-ended questions, drawings, quizzes, and then at the end it'll give me total participation. So that grade is what you get out of the total points available. So for example, if you answer 80% of the questions and slides and things, then you're going to get 80% of 30 today. So this Nearpod is going to be worth 30 points. If you answer all of them, you get all 30. If you answer fewer than that, then you don't. So that's what I'm saying is you need to participate in this, make sure you're staying up to date on this and checking in at every question. Does anyone have any questions about this before we move on?
No.
All right, sounds good. Okay, so today we're going to be talking about the scientific method. And the scientific method is a set of rules, and it's a logical process that we use in order to solve issues. So we're going to learn about the way that we go about it today. So this process is organized and it's logical. So what you do is when scientists come across something that they want to know more about, and this could be anything, they observe it, they see the problem, they see the phenomenon, they see what's happening. Then they make guesses or a hypothesis about what's going to happen or how they could change it or learn more about it. Then they run experiments to figure it out and test what they thought, and then they come to conclusions based on how those tests went. Hey, I found that it was like this, therefore this is the cause. So you guys actually do this stuff all the time without thinking about it. This is just a common human nature type process to go through. For example, if you're in your house and you observe, all right, we'll start with observe. You observe that say you're watching a YouTube video and it's taking a long time to load. So you observe that the Wi-Fi is running slow. All right. So you make observations about this stuff. All right, my Wi-Fi is running slow. All right, I look around my house. Okay, my little brother's playing PlayStation. My parents are on a video call, or I'm on a class right now, or people are watching TV, or I'm in my basement far away from the router. All right, then you make an hypothesis. Okay, so if I, let's say, move closer to the internet router, which is where the internet comes from in your house, then my internet speed will increase. So you test it. So you might, if you're in the basement or up in your room, you might leave that place and go get closer to the router. And then see, maybe your internet speeds up. Maybe the video loads and then you don't have any more problems with it. All right, that is an experiment. Therefore, you come to conclusion. Based on the experiment, what I can conclude is that the farther I am away from my router, then the slower my internet goes. Or if I'm in the basement, which is normally concrete or brick, then I can't get a good signal. Or you can conclude that maybe there are a lot of people on the internet in my house right now. I need less people on the internet in order for my internet to go faster. So that's not a, in the lab with beakers kind of experiment, but that's an experiment you might do on an everyday basis that follows this process. So it's not as complex and scientific-y as you would think. So observations start with senses you collect. You're using your senses to collect information. So that could be, all right, I hear this. All right, this feels like this. It looks, feels, touch, stuff like that. The only one we don't use in this class is taste. Never, ever, ever taste anything. You don't know who had it last. You don't know who touched it last, especially with COVID going on. You don't know what if the last person that used this tool washed their hands. There are some experiments we'll do this year where you might use sugar and or salt, which are things you can eat, but you shouldn't do it in a lab. In some of the labs, we will be making salts or evaporating sugar. So you'll see what's left, but you should not eat it. So the observations can be grouped into two sets. The first set is called a qualitative. All right, it describes qualities. So there's the hint. It's a sciencey sounding word, but if you break it down, it'll give you the meaning of it. Quality, qualitative. So that's your senses observations. So that's like the solution was blue. It smelled sour. It was a large object. It was far away. It was small. Those are qualitative observations. Quantitative describes a quantity. A quantity is an amount of something. So that could be something like that. It weighed 50 grams. We used 20 milliliters of solution. It was it had, it was 10 feet tall. Those are things that are quantitative because they have a quantity attached to it. So really, they're kind of hard words to say, and they sound very similar. But if you break it down and go slow and look at this first beginning part here, that will tell you what you're looking for. So let's practice. So you're going to get 4 different situations here. These are 4 different observations. We do chemistry, we do experiments. The solution is blue. The solution is 10% copper, 90% water, or the solution reacts with the metal. Which one of those is quantitative? So think about the base word in it, and then tell me which one is quantitative. So on these, normally I would put like 30-ish seconds on this because you're selecting one answer, and that's it. So go ahead and select one.
Mr. Pink.
Yes.
What's the code?
It's in the chat. Oh wait, hold on, you weren't there. All right, here, I'll post it. Yeah, go to that link. Sorry about that. So which one of these is a quantitative observation? All right, so a quantitative, all right, so I'm gonna show you guys, we're kind of split right down the middle. So half and half, basically, all right? So let's go back. A quantitative talks about, observation talks about a quantity, how much of something. So if you look at these answers you have to choose from, which one talks about how much of something? Doing experiments in class, blue solution, 10% copper, 90% water, or reacting with zinc. So if you look at it, this one, C, is the only one that talks about a amount, a quantity, 90%, 10%. And that's why. These other ones are qualitative observations. You are observing qualities about what you're doing. You notice that we do this many experiments in class. The solution is blue. That's using vision. That's the sense. That's a qualitative observation. Reactivity, qualitative observation. So the correct answer is C. All right, so now we're gonna use your observation skills to observe this video. So in this video, when I give it to you, you're gonna have to hit play on it. I'm gonna watch it on my screen that I'm sharing with you, but if you wanna watch it for yourself, you're gonna have to hit play. It's gonna be a video of a science experiment that we're gonna be talking about for the rest of this class, so make sure that you keep this in mind as we move forward. All right, here we go. All right. Okay, so we just observed a science experiment, and now I want you to list what you observed. So an observation, use as much detail as possible. The more detail, the better. try to use complete sentences too. It just sounds better. If I'm describing this to students, I tell them that to give me enough details so that if I was blind, I could paint a picture in my head about what went on. So if I was blind and I couldn't see what was going on in the experiment, I want enough detail to fill that in. All right, so think about it like that when you're describing. Use a lot of detail, tell me everything that happened.
Wait, what we doing again?
So on nearpod, all right, we just watched a video, and I want you to list your observations of that video. So you'll type that in the nearpod.
You replay my video.
Okay. I'm gonna replay it then. All right, guys. So stop typing. I'm gonna replay it.
Mr. Perfect, please.
Yes.
Can you play the video again?
Yeah, I'm gonna do that right now. Can you guys see it on my screen?
Yes.
All right. So if your video is not loading, just watch it on mine.
Okay.
That's just colored water. All right. So anyone need that one more time? All right.
No.
Okay.
No, I seen it. And you asking us what on the question?
So what were your observations? What did you tell me everything you noticed in that video?
I feel like you used some water, some blue color, the change of color. It was a candle, put the bottom of it, and just lifted it up.
Good. All right, so type all that in.
Yeah, okay.
All right, probably another 30 seconds or so because we do need to keep this moving. All right, I'm seeing some pretty good answers.
Did you just type that?
Yeah.
We're not doing all that.
Make sure you stay on mute, please. Thank you. All right, I'm gonna start sharing a few of them that were good. All right. Here's a good one. All right, after the colored water was dumped into the pan, after the candle was lit, I saw the water going up and the candle was inside the bottle. It took out the flame on the candle. All right. Well, first the person put the water into a Chipotle bowl, and then the candle got a candle and put the candle in the center of the bowl. Used a lighter to light the candle, and put the glass cup over it, and the hot air forced the water to come up. All right, that's pretty good. So that's what I'm looking for. All right, so anything less than a sentence for sure is not enough detail. All right, so make sure you're using as much detail as possible. All right, so up next we got a hypothesis. So a hypothesis are the observations that we use to predict the outcome of an experiment. So if we change like this, then that will change like that, is what I want you to think. So if this gets changed, then this happens. These are often called if-then statements. Hypothesis, if insert the part about what you're going to change in the experiment you just noticed, then what will happen afterwards? What do you think will happen? Now, this is something I really have to make sure you guys are comfortable with, because it's okay if these are wrong. Hypothesis is not meant to be right. You do not get any bonus points or any points taken away if your hypothesis is right or wrong. All right? What I'm looking for is that you understand the experiment and you are applying scientific concepts to intelligently test something. So I have a lot of students who try to change their hypothesis after the experiment. I'll see them frantically erasing and moving things around. Don't do that. Your hypothesis is, if it's wrong, it's okay. If it's right, that's okay too. It does not matter if your hypothesis is right or wrong. I would say 99% of the hypotheses are normally wrong. Okay, people that are running tests in scientific experiments for a living, they are normally wrong. Hypotheses are meant to be proven false, which can be a good thing or a not so good thing. But it's very rare that a hypothesis cannot be proven false. Like, you are saying that this is true when you do this thing, and everyone tries it every which way and it's always right. That's rare. So don't be worried if your hypothesis turns out to be wrong. This is kind of the fun part about science, is that you get to choose what the experiment turns out like. So don't be worried about getting it right or wrong. All right, so for the next two questions, this question and the following one, they're gonna be your if-then statements. So this first part is the if part. So if you change this thing about the experiment you saw in the video. So what I want you to do is think about the experiment that you just saw. In that experiment that you just saw, what could you change about it? What's something you could change about it that could affect the outcome? So, for example, you could change the color of the water. All right, is it an example? Now, I don't think that would do anything, but that's what I'm looking for, is what could you change about that experiment to affect the outcome? So there's 4 things you could change. I gave you one of them. I give you guys about 2 minutes on this one, because you got to do some thinking. I would suggest just keeping it simple too. You don't got to do anything crazy. If it's not something that could apply, I'll let you know, but at least you tried. And remember, I'm looking for 4 things. Don't give me 1 or 2. All right, good work, guys. Excellent. Good work. I like what I'm seeing. All right, I'm gonna start sharing some of them because I like what I see. So let's see. Here's a good one. All right, I would change how big the bottle is or the candle size. See how much more solution can go up in the bottle. You can also change the color solution. All right, I like this. This is good. These are all good ideas of things you could actually change. And then let's see another one. All right, use a better bowl, change the color of the water, bigger candle, use more water. Those are all easy things to change that could affect how much water is sucked up into the jar. All right, so I like what I see. This is very good. All right, so make sure you guys get your answers in so you get credit for doing it. And I'm gonna move on here in about 30 seconds. And this is something you could do at home. If you have a bowl, a candle, and a jar, you can do this at home. All right, you stick the candle in the water. Make sure the candle is sticking up out of the water, or put it on like a prop. Light it, jar up top, and you can do this yourself. All right. All right, so out of those 4 things that you just listed, keep them in mind. What might change because of what you changed? So if you said, I'm going to use a bigger bowl, what would that change about the experiment results? So if you used a bigger bowl, would you expect more water or less water to go in? If you used I saw someone put down, used a plastic instead of glass jar, okay, would you expect more water or less water to go up into the jar because of it? There's another one. A flame, a larger flame. If you used a bigger flame, would you expect more water or less water to come up into the jar? That's what I'm looking for. So how would what you just talked about changing, what would that do to the experiment? That's what I'm looking for in this question. And then an explanation would help too. Like if you said, if I use a larger bowl, then I would expect more water to go in because there's more water available. Like that's even better. All right, I'll give you guys 2 more minutes. I know this one takes some thought. Not that today. All right, pretty good. All right, start submitting your answers. All right, here's 2 that I like. If you're still working, you can keep working and submit it. I'm just gonna send it, show you guys some good ones. All right, a bigger bowl will need more water. All right, more water might make the water go in the jar faster. I liked how you guys talked. I liked how this is Jalen's. I like how we talked about the speed at which the water would go in. All right. All right, if I used, this is Giovanna's, I like it. If you used a bigger flame, I would expect a bigger flame would use more water, I think is what they meant there. If the bowl would expect more water to come, good. If I used a plate instead to hold down the flame, it would be smaller, okay? So good, I like this. So if you used a plate instead of a bowl, it would be different. These are good things that you can change. All right, so last one we're going to do today is talking about hypothesizing. So what you're going to do is now you're going to combine those 2 thoughts. So you're going to pick one of the 4 that you just came up with. Pick one of those answers and put it into a hypothesis. So it's going to be an if, question 1, then question 2. So if I could change the amount of water in the dish, then more water would go into the jar. That's what you're going to be looking for here. So make sure you keep it, and I'll put this up as a demo. If, again, I'm going to use an example that I saw. I added more water to the pan than more water would be absorbed into the jar because there's more water available. So what's good about this is you have your if. So everyone should start with if. And then this first part here is what you had from 2 questions ago where I asked you, what is something you could change? So what is that thing you said you would change? Goes there. Then everybody should have a then statement. This is what would happen or what you're expecting to happen. So this is like a prediction you're making. You're making a prediction. You don't know if it's right or not yet. Then what would happen? And then bonus points if you get a because in there and you explain why. So this part is the minimum I'm looking for, an if then statement, and then An extra good answer would have a because and then explain why you think that. All right, so let's see. Here's a good one. If I use a bigger bowl with more water and a longer candle, then more water will go higher into the jar. Good. Let's see. All right. If I could change something, I would change the bottle size because I think the bottle would have more solution and it could fill all the way up. So this is good. This shows me that the parts are there. So if this, then what I would stick in there is then more solution would go up because. So some of these are pretty good. They just, I think we need to move this, some of the wording around. Okay. So pretty good job so far. And remember, this is about doing the experiment, trying something new. It's not about whether it went right or wrong. All right, so here's what we're gonna do. We are going to design an experiment that I'm going to try out myself, and then I'm going to record it for you guys since we can't do it in a lab, unfortunately, since we're not here. I'm going to do it. I'm gonna take the most common answers, and then I'm going to do it and record it. So when I do these things, we're going to talk about 3 different things here. So we're going to use a control. The control is going to be one that doesn't change, one we're comparing it to. It's something you do to compare the change in others to. So the control is going to be the video we watched today. That's the control, what we're comparing it to. When I do these experiments, we're going to have 2 variables, and a variable is something that changes. One is independent. If you're an independent person, you don't need anybody to, you don't need to rely on anybody or anything to do whatever. So you don't need anyone to help you pay for your phone or for your clothes or for your a ride somewhere. You don't need something to change. So that's independent. That's going to be the cause of the change. So for us, that would be increasing the bowl size, adding more flame, changing the color of the water, adding more water. Those things are that we change that are not affected by the experiment. That the independent variable is the thing that you are choosing to change. The dependent variable is the thing that will change because of what we changed. So the dependent variable is, in this case, going to be the amount of water going into the jar. So the amount of water is going to change, and that's what we're trying to change here in this experiment. So which of those things we talked about in the independent variables are going to cause the dependent variable to change? The dependent variable relies on the independent variable in order to change. So based on how the independent variable changes, then the dependent variable changes because of that. All right. So let's see if you caught on. This is the last thing we're doing today. Answer this. Which of these dependent, which were the, let me try again. In this experiment we watched with the jar, what was the dependent variable? Which one depended on the other thing to change? All right. Once you answer this, you are good to go. So I will see you guys again on Wednesday for study hall, and then on, okay, I always get this. I'm still learning the schedule. Thursday for class, where we're going to wrap this up. So in the meantime, I'm going to look at the hypotheses that you guys suggested. I'm going to set up this experiment, and I'm going to try it with multiple things that you guys said. And then I'm going to take that, and I'm going to go record it, and we're going to talk about it on Thursday. So which one of these is the dependent variable?